Right, so we're going to practice some more of these number property past paper questions, and this type of question is becoming quite popular with WJC, where they give you a list of numbers and then give you some mathematical clues to help you to home in on what that number is. So find the whole number, so integer they may say there, which satisfies all of the following conditions. So it's a whole number between 1 and 40 inclusive, so that means it could be the number 1, it could be the number 40, or anything in between. The number is a multiple of 4, so it's in the 4 times table, but it's not in the 8 times table. 3 is a factor of this number, so 3 divides into it exactly. And the number is a square number. Now often if they tell you it's between a certain range of numbers and there's not too many of them, I would write them all out. But because that means I'll be listing 40 odd numbers, then I'm not going to. The clue here that narrows that list down most rapidly is that it's a square number. So square numbers are numbers you get when you multiply a number by itself. So 1 times 1 is 1. 1 is a square number and it's between 1 and 40. 2 times 2 is 4. 4 is a square number and it's between 1 and 40. 3 3s are 9. 4 4s are 16. 5 5s are 25. 6 6s are 36. 7 7s are 49. Okay, well it's definitely not that because that's too big. So that single clue there means we're now not dealing with 40 numbers, we're dealing with 1, 2, 3, 4, 5, 6. So 3 is a factor of this number. So 3 goes into the number exactly. Well, it doesn't go into 1. 4 divided by 3 doesn't go. 9 divided by 3 does, so it could be 9. 16 divided by 3, no. 25 divided by 3, no. 36 divided by 3, yes. So the 3 is the factor, has now brought my list of numbers down to it's either 9 or it's 36. The number is a multiple of 4, but not a multiple of 8. So it's in the 4 times table, but it's not in the 8 times table. Well, 9 isn't in either. So that knocks 9 out, and 36 is in the 4, because 4 9s are 36, but it's not in the 8 times table. So the whole number that we're looking for in that case is 36. Okay, next one. Consider the following list of numbers. Using only the numbers in the list above, write down the 3 cube numbers. Well, cube numbers, just like square number, with a square number you multiply number by itself. Cube numbers you multiply by itself 3 times. So the cube numbers are 1 times 1 times 1, which is 1, not in the list. 2 times 2 times 2. 2 2s are 4, 4 2s are 8. Careful, often when you write that down you automatically then write 6. 6 would be 2 plus 2 plus 2. When you're multiplying, 2 2s are 4, 4 2s are 8. Not in the list. 3 times 3 times 3. 3 3s are 9, 9 3s are 27. So those are the cube numbers, 27 is in the list. 4 times 4 times 4. 4 4s are 16. If you're not sure what 16 times 4 is, well, don't be shy. Work it out using pencil and paper, because this is on a paper 1. 4 6s, 24. 4 down, carry the 2. 1 4 is 4. Add 2 is 6. 64 is in the list. 5 times 5 times 5. 5 5s are 25. 25 times 5 is 125. Again, if you're not sure, do it long way. 125 is in the list. A number that is both a square number and a multiple of 9. So square numbers, we've listed those earlier. 1 times 1 is 1. 2 times 2 is 4. 3 3s are 9. 16, 25, 36, 49, 64 is 8 8s, 9 9s are 81, 10 10s are 100. I want one that's a square number and also a multiple of 9. So that's in the list. That's not, that's not, that's not, that's in the list. That's in the list, that's in the list, that's in the list, that's not. That should have been 100, that's not. So one of those is my number, and it's also in the 9 times table. Sorry, I shouldn't have crossed that one out. What's the answer? No, it's not in the list. So I'm looking for which one of those is in the 9 times table. Well, 4 isn't. 25 isn't, 36 is. 4 9s are 36. So the answer is 36. A number that is a factor of 81 that divides exactly into 81. Now, if it divides exactly into 81, then it's got to be a number that is going to divide into that, leaving when you multiply it to 1. So for example, 4, there isn't anything in the 4 times table that ends in a 1. There isn't anything in the 25 times table that ends in a 1, or a 5 times table, but in the 7 times table there is, because 21 is in it. So if we do 27, double it, you get 54, triple it, 7 3s 21, so that generates the 1. 2 3s are 6, 7, 8. So a number that is a factor of 81 is 27. It goes in 3 times. Part B, using only 2 numbers from the list, fill in the spaces in the following statement. Dividing blank by blank and then rounding the answer to the nearest 10 gives an answer of 30. So to get anything near 30, I want a pretty big number in that list divided by a pretty small number in that list. So I'm going to go with 125 divided by 4. So if I do that here, 4 into 12 goes 3. 4 into 5 goes once, and then we get a decimal bit. And if I round that to the nearest 10, I get the answer of 30. So 125 divided by 4 is what we're looking for there. Question 3. So this was on a paper 2, so we can use our calculator to play with this one. Jonathan writes a whole number on a card. The number is between 55 and 83 inclusive. So one of those, so my number is going to be between 55 and 83. So I could list them: 55, 56, 57, 58, 59, 60. One of those is my answer. The square root of the number is greater than 8 but less than 9. So the square root is greater than 8. Now 8, if we think back to our square numbers, 8 squared is 64. Square rooting is the opposite. So if I square root 64, just to show you, get that out of the glare. So square root of 64 is 8. If I pick a number smaller than that, say 60, then I get 7.7 blah blah blah. The square root of the number is greater than 8. So that means that the smallest this number is going to be is 64, because anything smaller than that and the square root of it will be less than 8. At the other end of the scale, 9 nines are 81. So anything that's bigger than 81 isn't going to give me a square root that's less than 9. So I can knock out that end. So that's narrowed down my list. My number now is anything between 64, it's greater than 8, so it's not going to be 64 either. Anything between 65 and 80. The highest common factor of 49 and the number is 7. So that means that 7 divides into the number exactly because it's a factor. So 65 divided with, remember this is calculator allowed now, so we can speed this up. Does 7 divide exactly into 65? No. 66 divided by 7? No. 67 divided by 7? No. 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 70 divided by 7? Could be. 71 divided by 7? No. 72? No. $77 could be. So we've now got our list down to the answers either 70 or it's 77. 3/5 of the number lives in the 6 times table. So 3/5 of 70. So fraction 3/5 times 70 equals 42, and 42 is in the 6 times table. Check, divide by 6. Yeah. If we try 3/5 times 77, I get a decimal answer. I can't see it there, can you? Which is not. So it's not 77, so it must be 70. 70 is between 55 and 83. Its square root is that which is bigger than 8 and less than 9. The highest common factor of 49 in the number is 7, so 7 divides into it exactly, and 3/5 of the number, which is 42, is also a multiple of 6. Question 4. A fraction is written as a over b. The fraction is a multiple of 0.2. The fraction is greater than a half and it's less than 75%. So multiples of 0.2 would be 1 times 0.2 is 0.2. 2 times 0.2 is 0.4. 3 times 0.2 is 0.6. 4 is 0.8. As a fraction, that's 2 over 10, 4 over 10, 6 over 10, 8 over 10. The fraction is greater than half. So it's not that one and it's not that one, because a half is 0.4. Sorry, 0.5. The fraction is less than 75%. Well, that's 80%. So it's not that one, which means it's 0.6, which is 6 over 10. Or 3 over 5, either of those would be fine. Question 5. Find the answer to the following number problem. So we're allowed to use a calculator on this. First thing we've got to do is find the LCM of those numbers. So the lowest common multiple of 12, 18 and 24. So the lowest common multiple of 12, 18 and 24 is what we get with, if we list the 12 times table, the 18 times table and the 24 times table. So we could do this by first of all doing the 12 times table. So we get 12, 1 12 is 12, 24, 36, 48, 60, 72, 18 times table, 18, and then so 18 times 2. Okay, so 36 is in both of those. 18 times 3, 18 times 4, 72. Right, let's try 24. 24 is 48. 24 times 3 is 72. So the LCM of those three numbers is 72. When it comes to highest common factors, so the common factors of 36, 1 and 36, 2 and 18, 3 goes into 36, 12, 4 goes in 9 times, 5 doesn't, 6 goes in 6 times, and then 7 doesn't, 8 doesn't, 9 does, but then you're repeating yourself, so you stop. So those are the common factors, the factors of 36. With 54, we've got 1 and 54, 2 and 27. Does 3 go into 54? Yes. 3 goes in 18. Does 4? No. 5 doesn't. 6? Yes. 7 doesn't. 8 doesn't. 9 does. But then we're repeating. So the highest common factor of 36 and 54 is the largest number that is in both tables, and that looks to be 9. So the highest common factor is 9. So find the answer to the following. The LCM of 12, 18 and 24 is 72, divided by the highest common factor, which is 9. So 72 divided by 9 is 8. So that's question 5. Question 6. So when we did the properties of number revision notes the other day, we did look at this on the front there. So when you adding and subtracting, those were the properties. But what I said to you was, you don't need to learn those, because if you're given a question like this, you just try things out. So if we've got, so let's read the question. So two types of number are added or multiplied together. Complete the table below to show whether the answer will be odd or even. One answer has been filled for you. Even plus odd. So if I choose an even number, 4, and I choose an odd number, 5, 4 add 5 is 9, which is odd. So if I have an even and an odd, I end up with an odd. If I have an odd and an odd, so let's say I have 5 add 7, I get 12. So when I add two odds, I end up with an even. Even times even, 4 times 6, 24, even. Even times odd, 4 times 5, 20, even. Odd times odd, 5 times 7, 35, odd. So they're marking this, but there's nothing to stop you picking numbers that suit the criteria and figuring it out. And finally, question 7. So express 315 as a product of its prime factors in index form. So we start with 315. It's not prime because it ends in a 5, so I can divide by 5. If I'm not sure how many times it goes in, I can wander off over here and do a non-calculated division. 5 into 3 doesn't go, so you go 5 into 31. 5 6 is a 30, remainder 1. 5 into 15, 3 times. 63. Is 63 a prime number? No, because 9 sevens are 63. So I can divide 7 into that 9 times. Is 9 a prime number? No. 3 goes into it 3 times. 3 is a prime number, so I can stop. So 315 is 5 times 7 times 3 times 3. To get the full marks, I have to write that in index form. 3 squared times 5 to the power of 1 times 7 to the power of 1. That's it. I've got my 3 marks for that. What's the highest common factor of 315 and 42? So this is one where I would go for the Venn diagram. I've already got my 315 in primes, so it's leading me down this path. So if I now do the same for 42, it's even, so I divide by 2, goes in 21 times. That's not even, but it's not prime, because 3 goes into it 7 times. 7 is prime, so I stop. So 42 is 2 times 3 times 7. Get my Venn diagram going. 315 there, 42 there. I'm looking for overlaps. So I've got a 3, which is common to both, and I've got a 7, which is common to both. Nothing else. So 315 will have a 3 and a 5 in that part of it, and 42 will have a 2 in that part. The highest common factor is in the overlap. So the highest common factor is 3 times 7, which is 21. 21 is the biggest number that will divide exactly into 315 and into 42. If that question had been for the LCM, the LCM, we would have got, it's not, but we'll do it anyway for a bit of practice. LCM will be all of those digits multiplied together. So 3 times 5 times 3 times 7 times 2, which is 3 times 5 times 3 times 7 times 2, 630. So the smallest number that is in the 315 times table and the 42 times table is 630. Didn't ask us for that, but seeing as we went to that trouble, it was worth refreshing our memory with that as well. So there you go. Those are number property questions, practicing squares, cubes, evens, prime factors, highest common factors, lowest common multiples, and so on.